So you can see this 360 degrees. I'm going to explain a few things about it, just so that you understand it. For a start, there's a seam on the front here. And if you follow that seam around, eventually it ends up on the back. So a seam that is both on the front and the back suggests a hole, and that the body is actually standing in it, so that the seam continues from front round to back. So you're in fact standing in a hole. That hole is a little bit like this. When you cut a hole, this hole is 100 centimetres in size. Just for no apparent reason, it's a rounded up number, but it's a number that I know I can get to. When you cut two of them into a rectangle like this, and you leave between them a fold that's called a valley fold, so it's like when you close a book together, it creates a V. They're sewn together and they're connected. And if I was to step through that hole, then what you're seeing here is a seam that's on the front, but which continues around here through the valley fold to the back. And that's what's happening here, starting on the front, and it's continuing around to the back. Often when people construct and make these garments, they'll say, where are the holes? Because they're often wearing the garment, and I'm like, you're in the holes. It's quite strange for people to understand where these holes end up being. If I'm making it for a dancer, or if I'm making it for somebody, usually I measure the hole depending on the largest part around a person. Never tight measurements, always easy measurements. You always need to make garments that allow for room of movement within them. And if I was making it for a dancer, then I would take a measurement that might be a kick stride measurement above their head. So you're building into the garment the ability to do that movement. If I'm working in stretch materials, I might make holes that are smaller than the body, but which have the ability to stretch so that they cling on. So you can make freedom of movement, or you can suppress freedom of movement, it depends. I sometimes work with, say, Nike, for example, the design company, to do dynamic sportswear, and for that we use much smaller holes, tighter materials, and therefore we end up with garments that sort of hug onto the body a lot closer. With this, there's volume, and there's room, and there's space. Now, between the valley fold, as the two holes come together, it creates what I call a sort of secondary tunnel. And you may, if you were to come over here, see certain areas of this dress where you think, oh, it's like a pocket. If you were to put anything into it, like say a purse or a wallet or a phone, you'd end up losing it because it actually continues through over here. So it's no good for anything valuable, but it's quite good for a sword or an umbrella or something like that, if you're worth enough to be carrying one of them around with you. What that is when the holes connect together and it creates a valley fold between it, it creates a tunnel on the outside of the garment. And it's a bit like a sort of little wormhole that starts in one part of space and ends up in another part of space. So it has some sort of vague scientific reference to my sort of inspiration. Another thing is there's another hole, if you turn to the back here, which is here. Now this hole starts on the back, and it continues through a valley fold tunnel, and it comes out over here somewhere. But that's on the back, and it's staying on the back. So the body isn't passing through this particular hole. It's only passing through one pair of holes. And you'll see that when I take it apart. What this is sometimes interesting for, these extra tunnels, is I like a garment just to flow and to do its own thing. But potentially you could, if you were to put your arm through this that way, perhaps this could be incorporated into a sleeve. If you bend your arm, are you able to bend your arm? Yeah, perhaps you are. If you just turn sideways on that, perhaps these tunnels on the outside could become sleeves. It's potentially possible. So once you've made a shape, you can then drape it, you can fit it, you can make it the shape that you want it to be. But it sometimes takes some secondary work if you want to play around with it a little bit more. If we just come over here just a tiny bit more. So if I just remove that from here for a second, and then I drop it down here. Another thing about it is it's got a point here, and there should be another one somewhere else. Over here. It's got 2 points, and so the points suggest, if it's got 2 angled points like this, it suggests that maybe this thing might be maybe rectangular or square, the original shape. We'll see when we sort of go through the construction process of deconstructing it, of dissecting it apart. To do that, I'm just going to put a couple of little simple balance marks on it. So on the front seam here, which I'm going to split, I'm going to just put a line across there and call it A to A. And if you turn to the back, on this second hole here, which is the one the body's not going through. I'll do that in red because it's black and white. I'll call that one B. So I've just made some little, the only reason for doing this is that when I take it apart, it allows you to sort of understand how different points come back together again. The first seam I'm going to cut apart, I think, is going to be what's called the side seam. This has a side seam. The side seam often starts under an arm, or depends where for a top anyway, starts on an arm and it ends at the hem. But this particular seam, it goes down here and it doesn't actually end anywhere, it just ends in the middle of nowhere. So it just seems to maybe double back on itself, so that perhaps suggests a loop of some kind. On this side, it's a longer one. It starts here and it continues until this point over here. So it's a longer version on this side. So that means it's asymmetrical, but also another loop. So I'll take one of these apart first of all, so we can just have a look at it. I'll do the shorter one first. So when I do this, don't feel it too much. I'm not going to hurt you in any way. But it is going to involve some whipping. So if you turn sideways this way, you begin to see that there is a hole that the body started on the front, and the body is actually passing through a circle here, which is just going slightly. And this is a looping. There's a loop here. If you then turn that way, I'll undo the other one. This is a longer one. So that too loops around. And now we have exovision. We can see into the garment. We can see that the body is passing through a hole that started in the front and has gone onto the back, and because of gravity, falls downwards. So the body's passing through it. Just give you a little turn around that way, and then to the front. I'm going to keep spinning you around, and you eventually probably feel dizzy. So the next thing I'm going to do is take, I think, apart this. No, I'll take apart the hole at the other back because the body's not passing through, just so you can see what happens here. Now this is two circles, two circular holes. I'll just do it on the wrong way. I quite like the fact that at some point I'm going to mend all of this with some gooey hand stitch back together and darned. So what we have here, before I just sort of slightly ripped it off grain there, is we have a circular hole. And that hole was constructed to be big enough for the body to pass through. And it's, these holes, this hole here is circular, and it connects to another hole over here. So these two were just joined a second ago before I cut them apart, and now they've been released. Two separate holes from each other. Turning back towards the front, we're going to do the hole that you're actually passing through. This is actually, this is all cool. This is the last hole that I'll be taking apart. And with this one, by releasing that, just turn back to the front a second, it means that this drops down suddenly. I don't know whether you're able to step out of that carefully. Tripping on it, lovely. So now we have this hole, which is big enough for the body, the hips to pass through. There's a measurement, there was a nice easy hip measurement connecting to this one here. And the body was going through that a minute ago, tunnelling through it. If we just give a little just twist around so you can just see what's happening on all sides here. It is quite a complex shape, obviously, when it's looking like this. But is it really complex? I don't think it's really that complex when you're actually going to see what it is really made from. I'm just going to release the shoulders so that we can take it off the body and see it as a flat piece. By the way, I actually made this pattern from scratch step by step, but there was no flat pattern for it until now. This is the first time I'm going to see the flat pattern, so until this point, the pattern has really existed only in my memory, and also in my actions, in my movements of my body, when I'm actually drawing lines, because I draw them not with rulers, but by a hand. And so my physicality gets involved in the pattern, and I'm now going to see where it was I made holes, joined them together, and created certain lines. And it'll be an interesting thing to see the first time. Thank you so much. And having good balance as well. If you can hold that end and that end, like that, and I'm going to hold this end up here. So it had two corners, if you remember. So it is actually just a rectangle if you see it this side. It's a rectangle that's made from a cream material. It's about 3 meters long. I don't actually measure 3 meters. I just measure 1 arm length, 2 arm length, 3 arm length. That's my 3 meters. But this is about 3 meters long in cream. And then on the other side of a contrast material, stripe. The only reason I choose these materials when I'm prototyping is that when people prototype, they often work in this material here when they're making garments. It's called calico or muslin, and it's very, very industry-wide and in education used a lot to prototype garments in. But this material is very unlike any material we might actually wear. It creases a lot. It's kind of it's not a very forgiving fabric in that it remembers all its creases and it shrinks very easily. What I love about it, it's got a lovely smell of hay when you iron it. But other than that, it's not a very good prototyping material. And yet, there are plenty of waste materials around the world, from market stalls and warehouses that sell end-of-line fabrics, where you can buy fabrics much cheaper than calico, because calico is actually fairly expensive, to prototyping. So I like to work in bed sheeting and other kind of materials that are softer, more fluid, because they're more like the end garment that might be being made, which in this example is a dress. So always choose the prototyping material that better suits the end product. Don't just use it because that's what you're supposed to do in education or in industry. That's a kind of just a convention that is an unnecessary part of the making process. So I'm now going to just give this end to you and split open this so we can lay it completely flat. And that way I'll be able to actually stand in it and sort of walk around it a little bit more like an environment, as if it was an architectural piece. The longest one of these garments I've ever made is 32 meters long. And 32 meters is quite a large space. And if you're measuring or making a garment that's 32 meters long, which is like from that wall to that wall and back again and then a bit more, you don't want to be measuring using centimeters or inches, because it'll take you all day. You'll forget the number and have to start again. It's much better to use a number that's maybe a stride or a step, or maybe just a measure by eye, or use within a space. This has got squares. This is a beautiful measured space already that you could work, use certain things like chairs or things in the space to measure by. And it's not an inaccurate way of measuring clothes. The more you get used to practicing it, you can become exceptionally accurate at measuring by eye or by measuring in a chair or a foot or a stride or a jump. People often think that the numbers and the tools are what make the process exact and replicable, but you can also make your own, and you can also measure very, very accurately without them. Now we have a very large piece of material which we're going to lay on the floor, and I'm going to move. I'll leave this down there so you can sort of see it. Just pull that corner out and lay this down like this. Now this geometry uses sort of like a moving angle that goes between worm's eye view and bird's eye view. And it uses a front and a back, which these are just like sort of shaper patterns to get the necks right. This is just a prototype, so I get the neck in a certain shape I like. That's the front, and that's the back. And then the side seams looped, and so I just simply draw a freehand line to loop those side seams together on that side, or on this side to join these two together. And it's literally just done like, and it's a human line. It doesn't. If you go up and down, it's more complicated as so. But why not? If you want to, you can move around that line and make it a little bit more unusual. I'm just going to take a quick picture of this pattern so I can see it. I don't think I'll see what this gets. This is hole A, and that joins the hole A here. So these two have a relationship with a valley fold between it, and that was when I put my hand through in the first instance that came out the other side when I was talking about there being a pocket. That's actually where I put my hand through, just there. There's then two other holes that have a relationship with each other, here and here, and they join together too, but the body didn't pass through that one. It could have, but it fitted better without it. Just going to stop this now. This garment rises upwards from a bird's eye angle, a little bit like, this is just the top layer only. Here we have a back and a front, and the side seams have been looped together. You might loop them symmetrically, or you might put them onto different angles. In this example, they've been put onto different angles because that goes with the grain of the material. So they're both on bias grain lines. When material has warps threads and weft threads when it's woven, and if you put it onto a 45-degree angle of that, it stretches a bit more. Now we call that the bias grain line. Now this isn't bias perfect, it's bias-ish. So I never really measure it being 45 degrees, I just put it on the angle I think is about right. And it just gives it a little bit more flow when it's on the body, it stretches a little bit more and is a bit more kinder to the figure it's hugging as it drifts down the body to the ground, its gravity takes it downwards. With something like this, it works from an aerial viewpoint, and the first step of construction, once you've made this first hole, that's one hole made there, is you take the back and the front, and the garment rises upwards, like this. You close your shoulders, and then you close your side seams together, which are the looped side seams, and you end up with something very fitted, but also has lots of volume in the bottom. And that's what that was made from. That's the very, very first hole. And it makes a very long tube. Now, how the holes connect to each other, a little bit like this. When you have a tube that's very long, longer than the length of the body might end here, but you have more than the length of the body. I've got my back and my front, and they just fold together. You close your shoulders and you close the side seams. You turn often the seams onto the inside when you're making garments. Although I'm teaching kind of radical pattern cutting, I like my seams to be on the inside where they should be, but if people want to put them on the outside instead and expose the seams, they can. They can be a punk about it if they want. That's totally up to them, but I like my seams to be inwards. It makes a garment that from the front and the back is just a very, very long tube, too long to be worn. So the first thing you do, if I was going to subtract this, I would fold it once to the front, turn it over once to the back, turn it over once to the front, and it makes a zigzag, like this. What I call a concertina. And you'll notice that there are valley folds here and there, and then there's another one there. There's 3 valley folds. This term valley fold is a thing used in origami. A valley fold is when a book comes together. These other folds here are what are called mountain folds. It looks like the peak of a mountain. I hate origami, but I just like the terminology that's used in it. Now, if I put a pair of holes big enough for the body to pass through, like we know because we took it off the body, that the body could go through this hole, then if I put a hole above it, big enough to get through, and I use the valley fold as a mirror line for its pair on the other side, I can begin to pair holes together, which gets sewn, like the one I stood through a minute ago. They can be sewn together, and that creates a route through a tube that is playing with the geometry of a shape like this. I folded this in a straight line, so it's not actually doing a very exciting shape. I'll show you what this looks like in the slightly larger version, just so I can get my hand to it. I have here a front and a back that's been folded over. Close your shoulders, close your side seam. You have a tube too long to be worn. You then fold it once to the front, once to the back, and once to the front. The reason you go front, back, front, back, front, back is that it distributes the weight of the garment evenly and hangs on the body with more not symmetry, but more balance. So that the back doesn't weigh more than the front and doesn't drag the neckline. It creates a garment. When you join pairs of circles through a valley fold line, they join together. So A sews to A, and then B sews to B, and then C to C. What happens is that the holes all vanish onto the inside of the garment, and your body will pass through the hem and the bottom, through the first set, through the second set, through the third set, and out to the top. And you wouldn't see my hand or my body because they'd be joined together. And also, it's not fabric. The fabric isn't paper. It's textile that has drape. So it's going to collapse in a way that is quite unpredictable. When you see this as a garment pattern, though, you can see that it has two geometric viewing points. You can see it like a person standing up, which is what I call a worm's eye view. So it has a foot and a head. Or you can float above it like a bird from an aerial angle and see that the body is coming in through here, through there, through there, through there, through there, through there, through there, and it's tunnelling through the pattern. It depends on which viewpoint you decide to look at this pattern from. Now, to take this one step further, you make two fabrics. We've got stripy and we've got plain. So here's an example of stripy and plain. The back is stripy, the front is plain. Now, how you put fabrics together is up to you. Every fabric is different, but it could be transparent and opaque, it could be heavy and light, it could be stretchy and non-stretchy. Those dynamic properties will play out in the make of the garment in an unpredictable way. But it's through practice, and then you gain the expertise of what those fabrics could potentially do. You have to try. You can't sit at the safety of a design board doing a pretty picture of a garment thinking, oh yeah, I know what it's going to end up looking like. You don't. You have to make it. It's only through making that you'll ever realise what might possibly happen. Particularly when you start to fold, instead of straight lines, you fold at angles. There's an angle, it's not an angle of 45 or 22 or 78, it's an angle of your choice. Everyone will do it differently. But back to front, we now fold at angles instead. It still makes a concertina, but one that is now beginning to spiral around the body. I don't know if you can see on here, but we have this way of orientating three-dimensional shapes. We often give them names. And in fashion design, we often say, this is the front, this is the back. And the line in the very middle of this front, we call the centre front. The centre front line, where one left or right mirrors to the other side, and then the back, the centre back line. And these are mirroring lines of symmetry, which aren't really present in the body. It's a bit like when we have a globe of the world. We have north, south, west, and east, and west. Now, we orientate countries and places according to these directions. We say people live in the east, people live in the north, south. But of course, that only works on a flat map. It doesn't work on a three-dimensional object, because if you travel north, eventually you will be traveling south. If you travel east, eventually you'll end up in the west. That's the way your three-dimensional object works. And it's the same with the body. We call things left, we call things right, we call things back and front. But now, when we fold at angles, we're actually spiraling around the body. So if you go towards the left, eventually you will end up in the right. It's the way that the body works, as it's a three-dimensional object. It's not flat. So we need to sort of like evolve our process of understanding that when it comes to three-dimensional, when it comes to a pattern. If we have a valley fold line, they'll be folded at angles. So I have a hole here that mirrors across to its pair on the other side of the valley here, and then there'll be one here to here. I'll show you a bigger version so you can see. All of these are angles to each other. They're not in straight lines, the way we circle the pairs are joined together. And that has the effect of really changing the shape of the body 360 degrees around it. We have a stripy front and a plain back. We make it into a tube by closing the shoulders and the side seam, so now it's too long to be worn. We fold it at an angle once, twice, and this time 3 times. If it was 32 meters long, you keep folding, keep folding, keep folding. Every time you fold, it gets shorter. Every time you subtract pairs of holes, it gets lighter in weight. So you control the weight and the volume and the shape in time through practice by the removal of space. And that removal of space gives you room to be within, but also change the outer geometry. A sews to A, B sews to B, C sews to C. Now when you start folding at angles, weird things happen, because the back, which is plain, ends up on the front, which is stripy. And the front, which is stripy, ends up on the back, which is plain. And if you follow the side seam, this is the right side seam, it zigzags and ends up on the left. And the right ends up on, and the left ends up on the right. So what's happening is back is on the front is on the back, left is on the right is on the left. And the only reason for that is because it's going around the body this way. As a world is, you go east, you end up in the west. Same if you go left, you end up right. If you go front, you end up back. We're working around the body, and that's throwing the material around in a very unpredictable way. For our brains, we can't figure it out on paper beforehand. We have to make it in material. Through making, we learn, we understand. So A connects to A, B connects to B across diagonal value fold lines. And through cutting one hole for the head and neck, 2, 3, 4, 5 holes in this dress. But I call this dress a 6-hole dress. Can anyone imagine where the 6th hole is? So they will think, where's the 6th hole of this particular garment? I've got one here, 2, 3, 4, 5, but it actually has got a 6th hole in it. Any thoughts? The hem, are you saying? The hem. The hem, of course, is a hole, because otherwise you wouldn't be able to get into it. So it starts with a hole, but of course that's on a different geometric plane. It's not with these holes, we see them from above. With that hole, we see it from a worm's eye view. So it's twisting geometries here as you come in through there, through that hole, through here, and then it rises upwards. And these holes just pull the fabric inwards. And that's what creates the shape. Simple as 6-hole dress.